This is PreCalculus 12, Chapter 4.3. We're going to be looking at composite functions. This is a little bit different than what you've done. We take the output of one function and use it as the input to another function. And this can happen more than once. This composition is frequently used in business. So let's say there's a company, they make a product, the product is P, we plug it into our cost function, we get X. And then there might be a distributor, and they'll distribute the value X, and that price will be Y. Then we take the Y, the wholesaler will mark up their price to get Z. And the retailer will mark up price Z to be U. And then you'll have to pay taxes on your U, and you'll get V. And when we do these functions, this is called f of g of x, and we can write f and a little circle g of x, and we say this f of g of x. So we can write v as a cost all the way from the beginning. So this would be t of r of w of d of c of p. And for every left bracket, we need to have matching right brackets. To make it less confusing with brackets, we can use this notation. So we have bracket t of r of w of d of c of p. And in general, you'll find that f of g of x does not equal g of f of x. And compositions still follow BEDMAS rules. So composition will follow the brackets. So for example, we have f of x equal to x plus 3. We have g of x equal to x squared minus 4. Let's compute f of g of x. BEDMAS says we do what's inside the brackets first, so we have to use the inside the brackets here. So we find g of 1. We substitute 1 in for x. So 1 minus 4 is negative 3. Now we take our output of our inner function and use it as our input for our outer function. So we have f of negative 3. We substitute negative 3 for x with brackets plus 3. This equals 0. Let's do this one now. We do what's inside the bracket first, f of 1. We substitute with brackets plus 3. This equals 4. This becomes our input to our outer function. So we do g of 4. This is 4 in brackets, squared minus 4. That's 16 minus 4, that's 12. Now, we can calculate explicit functions for f of g of x. We just substitute with brackets. So we have x squared minus 4, x squared minus 4 inside the big brackets. And then we finish this expression plus 3. And we simply remove the brackets because it's just an add. So we have x squared minus 1. So we substitute f of x, that's x plus 3. And that gets substituted for that x. Now we need to square and minus 4. So we FOIL this. That's x squared plus 6x plus 9 minus 4. Simplify, we get x squared plus 6x. And 9 minus 4 is 5. So we can do this calculation again with this expression. And we substitute 1. 1 squared minus 1 equals 0. And that's the same answer as this. We're going to substitute 1. So 1 squared plus 6 times 1 plus 5. That's 1 plus 6 plus 5. That's 12. And we get the same answer as this. So if you're just doing one calculation, this is the best form to use. If you're using multiple calculations, you would use this because it simplifies the amount of work you have to do. We can also do this graphically. Okay, we're doing f of g of 1. We have to do the inner one first, so we do g of 1. This is 1. And then we go down to the function g, and we see this value. So g of 1 equals negative 3. So we make our mark here. We want f of negative 3, and we're actually already there. And f of negative 3 equals 0. Again, that matches the answer that we've calculated before. And that's good. Next, we're going to do g of f of 1. So we have to do the inside first. So we do f of 1. That takes us to 4. Now our 4 is our input for g. So we go to 4, and then we go to wherever g is, and that's here. And we see that g of 4 equals 12. Again, that matches our answer, and that's good. Finally, we can use tables. Again, we do the inside first. G of negative 2 equals, so we have to use the right table. This is g, and our input is negative 2, or our output's 1. Next, we do f of 1. We need to use this table, and 1 is here, and our answer is negative 1. Next, we do the inside first, f of negative 2. F is here, negative 2 is here, our output is 0. Now we do g of 0. We use this table, we go down to 0, and we see that the value is negative 2. F of negative 1, so f of negative 1. We use this table, negative 1 has an output of 1. Now we do f of 1. And f of 1 is negative 1. And one more example, f of 0, that is 2. G of 2 is 0. Now for something harder, the backwards problem. And a lot of students have difficulty with this because you have to go backwards on the graph. So we want to find out what is A. We have f of g of A equals 4. Okay, so we're looking at this. We know f equals 4. So f equals 4 here. And the value to get that is 1. So f of 1 equals 4. Now, we know g of A must equal 1. G of A equals 1, because that's what we have here. This 1 is inside the brackets. G of A is inside the brackets. So we can equate the two. So now we're looking for 1. And 1 is along here. And we know G of A equals 1. So our answer could be here, or it could be here. So we see that we have two answers. A equals 2.2 or negative 2.2. So that's a slightly harder one to be able to see that. Let's look at the next question. We have g of something. G of something equals 12. We see 12 here. And the x value is 4. So now we need f of something equals 4. Remember, the inside of this bracket is this, and because it's that, we can make them equal. So now we go along 4 again, and f of 1 is equal to 4. Linear inverse functions revisited. So this is the property. If f of g of x equals x, then f and g are inverses of each other. And substitute using brackets. Although only one test is needed, do both to verify your algebra is correct. And what I mean by this is g of f of x equals x. So either one you can do, but if you want to check it, do the other one as well. Let's look at some examples. So f of g of x, so we're doing f of g, that's x plus 9 over 4. And this becomes 4 from there. X plus 9 over 4 minus 9. And because this is one term, we can cancel this out. So we're left with x plus 9 minus 9, and that's equal to x. So f and g are inverses. Let's try it the other way around. So we have g of 4x minus 9. Now we substitute. We have 4x minus 9. That's brackets. That's the x. Plus 9 over 4. And because these are just additions and subtractions, we can remove the brackets. We cancel out the negative 9 with the positive 9 because there's nothing in between them. And now we're left with 4x over 4. These cancel out, and we have x. So again, f and g are inverses. Let's look at another example. F of g of x. And I'm just going to do brackets here. X plus 6, because we're doing the g of x. Minus 7. So we distribute this, we get 3x over 2. And we get 6 over 2 times 3, that's 9. And this does not equal x. Okay, this is 2. This needs to be 0. So f and g are not inverses. And if you wanted to test it again, we'd substitute the other way. We need x. That's going to be f of x, 3x minus 7, plus 6 over 2. Again, we can eliminate the brackets. We get 3x over 2. Now we get negative 1 over 2. And again, this does not equal x. So f and g are not inverses. And we can use the calculator for composite functions. And we're going to skip the calculators for now. That'll be presented in a separate video. Let's look at a harder question. And this is similar to 9C on page 300. F of x equals the absolute value of 3 minus x. G of x equals x minus 6 all squared. H of x equals square root x. Determine f of g of h of 5. So we start off h of 5 equals square root 5. We substitute the 5 in. Because it's positive, we don't need brackets, although it's not wrong to put brackets there. Please do not put equal signs all over the place. They have to actually be equals to have an equal sign. Now we're doing g. This becomes the parameter for g, so we put in square root 5. So we have bracket square root 5. Now the square root is brackets by itself, so you don't need to add extra brackets, minus 6, all squared. We need to expand this. So square root 5 minus 6, square root 5 minus 6, but root 5 times root 5 is 5. This is negative 6 root 5. This is also negative 6 root 5, so we have negative 12 root 5. And then we have negative 6 times negative 6, that's 36. Now we have f of this expression. We might as well simplify this. This is 41 minus 12 root 5. 41 minus 12 root 5. And we plug this into x. This is absolute value of 3 minus. This time we need to substitute with brackets. 41 minus 12 root 5. Now this, we can flip the signs in here. So this is minus 38. 3 minus 41 is negative 38. Minus minus, that becomes positive 12 root 5. And we can always simplify the absolute value by figuring out which one of these is bigger. And since this is no bigger than 3, okay? It's bigger than 2 because the square root of 4 is 2, but it's no bigger than 3 because the square root of 9 is 3. 3 times 12 is 36. So this is more negative than this is positive. So we flip the whole thing around and we get 38 minus 12 root 5. And this is the final answer. So if you're given a question like this, answer without a calculator. This should be exact and not a decimal. You will lose marks on a test by using decimals. And that completes this lesson.